complete circuit. We have done this. Voltage I told you EMF is the total energy needed to move the charge through the circuit, right? It goes from which form to which form, non-electrical to electrical, right? So this is the EMF. এখানে syllabus একটা advantage কি ওরা যখন definition চায়, you can write this definition, and this is exactly the official definition. We will have a class though, not a class, like almost a week, just we'll go through every definitions out there. So what I'll do is I'll make you go through all the definitions, all the equations, all the relationships of everything, right? So it's like a review. All levels of course, so basically that thing, okay? তখন এটা clarify হয়ে যাবে. We have around 50 definitions and equations. আচ্ছা ওটা যদি পারো, you have guaranteed 20 marks in your exam. 20 marks just definition আসে, okay? So there's nothing to go wrong there if you study, obviously. Distinguish between EMF and PD in terms of energy considerations. We have done that. EMF is energy watt. EMF is energy watt. PD is energy watt. Fill in the blanks. EMF is the energy dash. PD is the energy dash. EMF is the energy in, PD is the energy out. Okay, in a circuit. So electrical energy into a circuit is known as what? EMF. And what is PD? The electrical energy out of the circuit. Okay. The approach, understand the effects of internal resistance and of a source of EMF and terminal potential difference. Eta hoche we will do after the Kirchhoff laws. Okay, it's a very important thing. The highlight curriculum, it's one of those things that is completely new for you guys. Okay, internal resistance bola hoy, eta amra soon korbo. Ajke jeta korbo is this. It's very easy. For me, it's very easy to teach because it will take like 10 minutes to teach, but it'll take a couple of weeks of suffering for you. The questions are very complicated. Okay, the theory is very simple here. And question of complexity, I'm going to explain before I get into it. To explain. It's basically series and parallel circuits. Remember from O levels? Now, series and parallel circuits, when I did in O levels, if you did it with me, I went to a lot of complexity eventually. Like, a series of either parallel, the branch, branch. I used to go like 1, 2, 3, 4 for increase in difficulty, right? It can possible. Because, circuits are complexity kono end nai. I can always come up with a more complex circuit out there, right? So if I keep doing that, we'll never end because I can always come up with a complex circuit. Luckily for you guys, right? A chapter 3 past paper question ashe, there are maximum 2 marks. I have never seen 3-mark question from this topic. It's a law, it's a thing and everything, but the questions are very limited. So what's their aim here? Their aim is not to drown you in the complexities of the question. They just want you to understand the basic fundamentals of it. Could be basic fundamentals enough. So 2 marks are beshi question ashe na. Why am I saying this? Because I know some schools will give you some of the questions that are like 10 marks. Honestly, exam jodi ashto there would be 10 marks, right? 10 marks is the question hoy na. So orjono I won't really be wasting time in those type of stuff. However, textbook e onekgulo bhalo question ase, I'll be doing all of them because that I know for sure is a standard because on the boita hocche made by the same people who make your question papers. Okay, so yeah, just letting you know, I'll draw a line somewhere and that line is where your textbook is. Or beshi complexity korabo na, past paper ja ashe is all easier than the textbook, so just don't worry about that. Right, so I'll be starting this today. Eta hoye gele we can actually call electricity more or less done, but eta hota hocche into time lagte pare. Okay, let's see. So what is this? It's called the Kirchhoff, whatever you call it, the laws are the same. So namta kono issue nai ekhane. So let me clarify what these laws are. So I mean page er moddhe pura law ta define korbo. Don't write anything. I'll just explain first and then pore tomra ja chao copy kore nite paro, okay? Right, so there are 2 laws here. Laws gulo hocche based on certain principles, and these principles that are applied here are principles that you have seen before. So amaderke just ki korte hobe, we have to put a name to them now. So the first principle that we're going to learn here is called the KCL, Kirchhoff current law. or also known as the Kirchhoff's first law. So KCL-টা কিসের উপরে based? It's the logic and law behind how current behaves in a circuit. So a law হচ্ছে, why are we learning this again, right? So there has to be a motive behind this. This law helps you solve circuits even if they're not series or parallel. So contrary to what students normally believe, circuits in series are parallel. Nah. In fact, circuit series and parallel they're usually something called hybrid, where there's like a very complex scenario where neither it's series nor it's parallel between those circuits, right? Ogla solve করতে গেলে what do? You have to use the laws, the basic laws, okay? So আপনারা বলে দিচ্ছি series and parallel, we know all levels, right? It's just lab it, practical work, not কিছু না. Real life, no one really works with those. They're a little bit more complex than that, okay? So we have to apply these laws. So what does the current law state? So the current law states that the Kirchhoff current law, the sum of current at a junction is always equal to zero. His words, actual words. Interpretation exact words. His official definition of net current divided by junction. Okay, the net current is zero at every junction. What does that, right? Let's try to understand. So first of all, what's a junction? So junction is a place where current can divide. And what I'm drawing right now is the simplest junction possible. It's just not possible. This is the most basic junction out there, right? So imagine you have a current coming here, which is I1, and the current is there I2, and then the current here is I3, right? So can you tell me, based on how current behaves, O-level knowledge, I haven't taught you anything new here, can you tell me what would the relationship between I1, I2, and I3 be? Yeah, I1, the current in, should have to be definitely equal to what? The current out? Are no possibility nai, right? So I1 should be equal to I2 plus I3. That's the relationship at this point, right? But what is this based on? What did you guys base your answer on? What was the logic? Key logic used for, sir. The current gets divided. So is it ever possible that I1, I2 plus I3, right, is actually more than I1? I2 plus I3 is actually more than I1 in this scenario. Is it possible? Why not? Why do they have to be equal? They branch from the same current. That's okay. I know you guys know this, but I just want to understand what's the logic behind it. The logic actually is very straightforward. It's called the conservation of charge. And the Kirchhoff first law, right, is based on conservation of charge. MCQ, it's a very common MCQ. What is the law based on? Conservation of charge. What is that? Charge can neither be created, charge can neither be destroyed. The number of charge that flows through a circuit will always at any given time be what? Same, right? So even if 10 electrons enter a junction, it is impossible for you to have how many electrons leave the junction. More or less than 10. It has to be 10. Do you get my point? So that's the thought process you probably had, right? But if you want to put it in words, this is how you put it. That the net current or the total number of charge in a circuit is always constant. It's called the law of conservation of charge. And it's a law that you have applied in chemistry in terms of charge and, balance in equations, right? Charge can never be created, nor you can destroy it. What can you just do? Move it from one place to another, right? So this whole idea, the first law, is based on the conservation of what? Charge. So এখানে যদি একটা junction x amount of current ঢুকে, ওই junction থেকে what amount of current should leave as well? The same amount. But definition to তা না. Look at the definition. The sum of current at a junction is always equal to zero, right? What does that mean? So that is actually just an extension of this. I'll explain what it means. So if I find all the current entering the junction, right? কি হবে? It's going to be I1 plus, do you think I2 is entering the junction? No, but definition says the sum of all the current entering the junction, right? So I2 যদি enter না করে and leave করে, how can I mathematically signify I2? Minus, because I'm looking for someone to enter the junction. ও তো সরে যাচ্ছে. So I'll signify that as what? Minus I2 plus what should I3 be? Plus or minus? Minus I3. And they said that if you add all of these up, what would you end up getting? 0, right? So let's see ki hoy. I1 minus I2 minus I3 is equal to what? 0. Do you think that there's any difference between this and what I said earlier, or what you guys said earlier? No, right? It's actually the same thing, because I1 is equal to ki I2 plus I3 na. If I had taken them to the left hand side, wouldn't I still end up with that definition? So back in the day when Kirchhoff came with the law, right, his understanding was that if there's conservation, what should the net value be at the junction? 0. আমরা ওটাকে একটু ম্যানিপুলেট করে আমরা যেটা বলি, and I'll be saying this quite often, total current in must be equal to what? Total current out. It's the same thing. আচ্ছা, so তোমরা যখন এক্সামের ডেফিনেশন বলবা, stick to like what he said, the net current at a junction is equal to 0. এটা কেন বলতেছি stick to it? MCQ যখন অপশনস দিবে, it's like I1 minus I1 2 এরকম করে equal to always কি থাকে? 0. But once you manipulate your equation, you'll see you'll end up with the same thing all the time. Okay. So yeah, this is the first law. So the first law states that the net current entering a junction is equal to 0. Which means conservation of charge base kora. So this law, the first law that you see here, KCL, right, is based on what conservation? Charge conservation. Okay. So the amount of charge in a circuit will always be the same with Rupert. So this is based on charge conservation. Right. So let's see if you can solve a question. We're done with this, by the way. I'm also it's very easy, but I can make questions very complicated. Okay. So charge conservation base kore, this whole law exists, that the total charge in a circuit, net charge in a circuit is equal to what? 0. Okay. Right. So আমি একটা question দিয়ে দেখো তো পারো নাকি example. যদি না পারো, যদি confusion হয়, I'll come back again. Don't worry. But I want to see what can you guys figure out from here. So I have a circuit here, and these are junctions. Okay, junction and junction. It is a series of parallel that I have drawn. Ki mone koro? Is a series or parallel? O-level knowledge to get parallel. What was the thing that made a series circuit parallel? Presence of a junction or a branch. Okay, a series circuit will never have what? A branch, right? So definitely there are branches here. I'm not probably showing you the full picture, right? But definitely what is there in the picture I've shown? Branches, right? So it must be a parallel circuit. Okay, so just letting you know the parallel to branch theke tale bola hoy. So let's say the current here is 10 ampere, the current here is 5 ampere, ekhane I1, eta hocche 3 ampere, এটা হচ্ছে I2. Find I1 and I2. Try করো, খুব ইজি একটা দিছি। দেখো, ট্রাই করো। Between 12, like here's something else. Yeah, I mean it's O-level standard question. Ki hocche ekhane? So you have current entering a junction, and this junction has 10 entering and 5 entering. So how much should leave the junction? Yeah, so the I1 is going to be 10 plus 5, 15 ampere, and I2 is going to be what? I2 is going to be এখানে 15 যাচ্ছে আর নিচে 3 চলে যাচ্ছে, বাকি কত থাকে? Yeah, 15 minus 3, 12 ampere. I'm trying to set the logic behind these. So বুঝছো কি হচ্ছে এখানে? So I'll now increase the difficulty. আরেকটা question দিই দাঁড়াও। Garbage in, garbage out. What is it? Do you guys know? No, I don't know either. Sorry, never heard. Apparently, ICT তে হচ্ছে garbage in, garbage out বলা হয় for this idea. Okay. I mean, we can just call it current. Garbage এ বানানো দরকার নাই. But yeah, I mean, probably it works the same way. I don't know. Right. Try this MCQ. This is one of the most complex questions from this, right? So because I feel like you can solve it, so try করো। Yeah, shit. B. Yeah. So বাকিদের পাওয়া উচিত, but let's see কি হচ্ছে। So how do I find I2? I2 is the current that comes here, and then it comes here, and doesn't it split up into two branches here? So I2 has to be the sum of these two branches for sure, right? So what is that? 20.2 and 10.6. What's the sum? 30.8, right? So I can't have A as an answer because oita hobe na, and I can't have C as an answer. So I2 has to be 30.8. But then if you look at this junction here, we do junction by junction, okay? So if you look at this junction here, you'll find that how much is entering the junction? 10.6. How much is leaving the junction? 10.8. So you have to feed current to it or extract current from it. Feed current 10.8 বেড়ে গেল না? So that means the current that you see here, right, has to be how much? 0.2, right? A minus কখন হবে? Minus আমি বলে দেই because এটা একটা answer আসতে পারে. What if this was 10.4? তার মানে current কমে গেল না? Doesn't that mean that the current has to leave the junction from the other place? তখন ওরা কিন্তু এক্সামে অ্যারোটা এটাই দিবে. They won't change that. কারণ the arrow is just a placeholder. আচ্ছা, what would the arrow value be? Minus 0.2. What would that imply? That the current is 0.2, but it's in the other direction of what the arrow is. Vectors এর মতন, বুঝছো? So yeah, just keep that in mind. হ্যাঁ, upward junction যদি consider করো 20.2 আসলে এখানে, right? And the current goes down here and the current goes front there. এখন now you need to figure out what's the current front, right? ওটা কেমনে বের করছো? 30.8 minus
added, so there must be 0.2 gone from the 20.2 in order.
হ্যাঁ, ওইটাই তো করছি আমরা।
But if I think in terms of that, then it should be -2 because it is leaving the junction.
No. Leaving the junction.
Like if I take it in terms of the upward junction, then I1 is leaving. So it should be minus 0.2.
It's not about leaving or entering. It's the direction of the current. Is the current down? And what's their arrow? Like the arrow they provided, is it down? Does it match your arrow? Does it match your arrow? মানে তোমার কারেন্টের ডাইরেকশন কোন দিকে? Downwards. ওরা যে অ্যারোটা দিচ্ছে ওটা কোন দিকে? So they are the same. That তোমার অ্যান্সার পজিটিভ। হ্যাঁ, আর তোমার অ্যারো যদি উপরের দিকে হতো and ওদের অ্যারো যদি নিচের দিকে হতো, what would the answer be? So because we are not answering here in terms of the junction, we are answering here in terms of what? The arrow they provided. ওদের অ্যারোটাকে আমরা রেফারেন্স ইউজ করতেছি। Their arrow is showing that current enters the junction নিচের দিকে, right? আর তোমার ম্যাথে উপর থেকে বের হোক প্রবলেম নাই, নিচে কি এন্টার করে? তাহলে তো ওদেরটা ম্যাচ হচ্ছে, so it will be positive value. Also তুমি মাইনাস নাও, এটা হবে না, if you add them out দেখবে জাংশনে ম্যাচ হয় না। Okay, right, so এখানে কোনটা হবে আনসার? বি। বুঝছো এটা? Right, so that's your logic behind these kind of circuits. This is called the Kirchhoff current law, or the first law. Okay, it's based on conservation of what? Charge. Is that okay? আচ্ছা, আমরা হচ্ছে পরেরটা যাই। Port is I would say the real deal. Port is what is the complicated part. So right, we'll do this again. এটা রাখলাম এখানে। Right, so second law তো দেখি আমরা এখন। Second law তোমরা করে আসছো, but not the way we are going to do it right now. So this is called the KVL, Kirchhoff voltage law. Okay. And this is what does the law state? আগে বলে নেই, তারপর আমরা চেক করি। So এই lawটা you have heard before. Can you tell me in terms of a battery in a circuit, right? And the components in the circuit, how does the voltage compare? So if I have a 10-volt battery that's fed to a circuit with 3 lamps in them, right? A 10-volt battery given to a circuit with 3 lamps in them. They're different lamps. If I add the voltages of all the lamps together, right, what should it be? 10, right? If I add them up, shouldn't be 10. And what was the voltage of my battery? 10, right? What's the logic here? What did you do? You assume that the total energy in must be equal to what? The total energy out. What do we call the energy provided to a circuit? The per coulomb charge. What do we call it? EMF, right? What do we call the amount of energy taken away by a circuit? ED, potential difference, right? So what does this law state? The law states that the sum of EMF is always equal to the sum of PD. একটু যদি lawটা হতো, your life would have been very easy, just O levels হতো, but they added something here. The sum of EMF is always equal to the sum of PD in a closed loop. The loop is what makes this complicated. Okay, so loopটা কি এখন বুঝাবো তোমাদেরকে। loopটা বুঝে গেলে this topic is done. So this is called the KVL. loopটা কি আমি বুঝাচ্ছি একটু পরে। KVL is called the Kirchhoff voltage law, and it is based on the conservation of what? If you can take a hint from what I said. Conservation of energy. One of the we are working with fundamental quantities out there. Charge at a fundamental quantity যেটার উপরে কি depend করে? Current, right? And energy is a fundamental quantity যেটার উপরে কি depend করে? Voltage, right? So this is energy conservation. Energy conservation, right? So this is the Kirchhoff voltage law, right? So as you can see, these are the two laws that we have, the first law and the second law. The first law is about the current in a junction, and the second law is about the voltage, right? Now let me explain it in the কাজ করে। So screen এ দেখো, I'll be showing you some new things here. Okay, so let's say you have a circuit here, and a circuit এর মধ্যে হচ্ছে you have a battery and You have the components out there. Just how to apply the law. So there are few resistors here. এটা ইকুয়েশন গুছাতে হয়, and আমি তোমাদেরকে বলছিলাম যে তোমাদের সিলেবাসে 2 marks বা 3 marks এর বেশি কোনো কোয়েশ্চেন দেয় না। তোমাদের সিলেবাসে you're not expected to solve the circuits, you're expected to what? Form equations with the circuits, okay? Well, in terms of I, in terms of V ওরকম. So this is EMF. EMF এর সিম্বলটা এটা ইউজ করা হয়, epsilon, okay? It's a universal symbol. There's current flowing through the circuit, which is I. That's the amount of current flowing through. This is R1, this is R2, this is R3, okay? They'll ask you to form an equation for this circuit in terms of I, R1, R2, R3, E এগুলো মিলে to form an equation, and using Kirchhoff's second law, right? So second law বলছে that the net, what did the Kirchhoff's second law state? That the total voltage or EMF in a circuit is equal to what? The total PD, right? But in what was the extra addition there? In a loop, in a closed loop, right? So what's a closed loop? Let's see. So pay attention. আমি draw করে এখনই start করব. So whenever you do these kind of questions, তোমাদের একটা জিনিস করে নিতে হবে. You first have to draw a loop like that. এরকম একটা loop draw করতে হয়. And which way do you draw your loop? It's up to you. এখানে তুমি লুপটা উল্টা দিকে draw করলেও same answer আসবে, তুমি এভাবে draw করলেও same answer আসবে. My recommendation, right, as a tip for getting your answers more easily, is to follow the direction of the current for your loop. তোমার কারেন্ট যেদিকে যাচ্ছে ওইদিকে লুপটা নিলে দেখবে অ্যান্সারগুলো ইজিয়ার হয়। What if you take your loop opposite to the direction of the current? What would be the problem? Nothing. Absolutely nothing. Same answer আসবে, একটু unintuitive হবে, মানে মনে হবে যে বারবার you're going against the natural flow of things, but answer same আসবে. Okay, let me show you কেমনে এটা solve করতে হয়. So the first thing you write down here is the sum of EMF. It'll be a statement you have to write down a lot in your electricity math. Sum of EMF is equal to sum of potential differences. That's the first thing you write down. Can you tell me, if I go across this loop, and বুঝে শুনে answer করো, as I go across this loop like this, right? What's the EMF that I face here? Man, is there any EMF I face if I go in a loop here? Man, আমি যদি এই যে এখান থেকে শুরু করে হেঁটে হেঁটে এভাবে করে যেতে থাকি, do I meet an EMF on my way somewhere? Yes, right? কোথায়? That one, right? So there is an EMF here in the circuit. What's the value of the EMF? E, right? এখন এটা কি প্লাস ই হবে না মাইনাস ই হবে? এটা কেমনে বুঝবো আমরা? So if your EMF is providing current in the direction of your loop, what would the EMF be? Positive. If the EMF is providing current opposite to the direction of your loop, what would it be? Negative, right? So এখানে যেটা mainly তোমাদেরকে দেখতে হবে is your circuit being fed energy or is the energy being taken away? It's been fed energy here, right? So it's a positive interaction. Is there any other EMF here? No, right? Equals to, as I keep walking like this, like that, do I face any potential differences here? Yes. How many? 3 of them. Can you tell me what's the potential difference across this resistor here? V equals to IR. What is my current? I. What is my resistance? R1. What should the voltage here be then? I, R2, because what's same throughout the circuit? Current. What should the voltage here be? I, R3. So if I put them all together, what's my sum of EMF going to be equal to? The sum of PD, what should that be? I, R1 plus I, R2 plus I, R3. Do you agree? Right? That's it. That's the equation. Okay, this is the most simplest form possible. It's a simple actually kora possible now. So এখানে কি হচ্ছে, the total EMF in the circuit is equal to the total potential differences that you have. Now, what if I had taken my loop the other way around? করি, just for the sake of it, because মাঝে মাঝে ভুল করে উল্টা loop নিয়ে নেওয়া হয়, কোনো problem নাই এটাতে। কি করতে হবে একটু বলি তোমাদেরকে। So if I had taken my loop the other way, এই কারেন্টটা বাদ দিয়ে দিলাম, এটা বাদ দিয়ে দিলাম। I took my loop, let's say, উল্টা দিকে। So the loop I had taken was actually this way. What would the consequence be on my answer? Okay, let's see. So current same current same right. This is my eye. Manora example, this is the eye. Okay. So as I walk through this loop, right? As I walk through this loop, do I meet an EMF on my way? Yes, right. but I'm walking this way. Is the EMF providing energy in the direction I'm walking or against me? Against me. Am I not going against the flow of the natural setup, right? So my EMF would be a positive value or a negative value. Yeah, again, sum of EMF is equal to sum of PD, but this time the EMF is going to be minus E. Okay, so that is it. What significance does the direction of the loop have against? Nothing. It's a convention to do your math. মানে কোন দিক থেকে তুমি start করবা. Okay, that's it. I'll tell you, it's similar to taking plus and minus in momentum. Which side is plus? Your wish, right? Your wish. Ekhano same. Which side is the loop? Your wish. Just math করার জন্য একটা convention লাগবে, right? What's the PD going to be here? এটা একটু interesting দেখো. So as I keep going here, do I face my potential differences? Yes. But as I go here and go through this, right? Problemটা কি হচ্ছে? আমি যেদিকে যাচ্ছি আর current যেদিকে আসতেছে are the same or opposite? Opposite. So can I take I as I or should I take it as minus I? Yeah, it's going to be minus I. So এখানে কি হবে? Minus I R1 plus minus I R2 plus minus I R3. So eventually notice করবা everything is what in this equation? Negative. Which also means everything can also be what? Positive, right? So তুমি যখন simplify করবা, which equation do you come back to? The one that we found earlier. আচ্ছা, again, one more time বলে দিচ্ছি, the direction of your loop should never be the excuse for your wrong answer. So it must be something else you have done. Clear? So direction of the loop কোনো সময় answer ভুল আসবে না. It's just sometimes it may make your life a little difficult, right? But it's not something that's gonna make your answer wrong. Okay. Right. So that's the basic foundation of it. But what else do we expect from this? Let's get into the more complex stuff there. Okay. Practice করলে আরো clear হয়ে যাবে। আজকে আমি start করে দিই। Next class we'll wrap this up. Right. Form an equation using E1, E2, I, R1, R2 for this circuit. So this circuit, you know, evaluate use for how many batteries do I have here? Two, right? So that. If it isn't the closed loop, current shouldn't flow. Correct. That's true, of course. The closed loop না হয় তাহলে math করা যায় না. E1 plus E2 equals to I R1 plus. Yeah, that's the answer. Okay. Ashif, একটা লুপ নিতে হবে. Don't be lazy. লুপ নিয়ে start করতে হবে. আচ্ছা, মানে there's no other way here. প্রথম একটু try করতে হবে. Eventually you'll get a hang of it. আচ্ছা, first say if you want to take shortcuts তাহলে problem. আচ্ছা কেমনে করতে হয় দেখো so the first thing that you need to do here is draw a loop whichever direction you want it's up to you আচ্ছা so আমার হচ্ছে recommendation হচ্ছে যে কোনো একটা কারেন্টকে ফলো করতে যে কারেন্টটা প্রোভাইড করা থাকে now once I do this প্রথমে I'll start from the top do I face a EMF as I walk from the top yes is this EMF pushing current out in the direction I'm moving or is it against my motion in my direction right so I'll consider this EMF to be what positive so again our there's a mark for this you have to write this all the time sum of EMF equals to sum of PD right so EMF 1 হচ্ছে in my direction as I keep going like this right like that and I come here and I face another EMF here do you think this battery is pushing current out that way or downwards and is that with my motion or against my motion yeah so this EMF will be considered to be what minus E2 because it's opposite to the previous one right equals to current ki hobe I R1 plus I R2 right so therefore yeah E1 minus E2 equals to I অনেক সময় এটা একসাথে করে দেয় আমি তার জন্য এটা দেখাই দিই তোমাদেরকে এটা লিখলে কোনো প্রবলেম নেই it's the same thing okay clear about this right so question থাকলে আমাকে বলতে পারো আমি একটা তোমাদেরকে আইডিয়া দিয়ে দিই এটা আইডিয়া না মানে it helps the other batches তো তোমাদেরকে প্রোভাইড করে রাখি it's a chart on কখন প্লাস হবে কখন মাইনাস হবে okay it's very obvious and intuitive একটা জিনিস but I have seen students struggle so এই জিনিসটা অ্যাড করে রাখি so when you're doing your math keep an eye out for this it is this chart here so chartটা একটু কেমনে পড়তে হয় তোমাদেরকে বলি a arrow represents the direction of your loop okay and this represents the direction of your battery so if your loop is this way and your battery is this way what do you consider it to be positive if your loop is this way but the battery is still that way what is it negative clear আবার তুমি যেদিকে যাচ্ছ ওইদিকে ওদের intended current তাহলে V equals to IR তুমি যেদিকে যাচ্ছ right intended current উল্টা দিকে what should it be minus IR because the current is the other way এই যে একটু আগে আমরা করলাম so এর বাইরে কিছু নাই absolutely nothing else other than these like any issue that you have here could have been just here okay what if we started from E2 E2 তে start করতে পারার কোনো problem নাই what if we started from E2 so if you started from E2 শুরু থেকেই তোমার কি হবে negative because it's still where you start doesn't matter plus নাকি minus হবে what matters which way is it pointing it doesn't change the fact that it's pointing the other way just because you started somewhere else it's always pointing the other way right so you can take a start pull it's minus E2 and you have taken the loop this way right at least I have taken the loop this way what if you are taking your loop the other way তাহলে E2 কি হয়ে যেত positive and what would E1 be negative but then everything else I1 IR1 IR2 also কি হয়ে যেত negative and once you simplify you'll come back with this equation okay right so I think you guys are ready for what actually comes in the exam so এটা করে আজকে যাবা okay I'm going to give a question এটা করলে we're done with a very big part of the chapter of course অনেক practice করতে হবে but at least you know this exists class time এর মধ্যে যদি নাও হয় একটু 5 minutes extra নেব okay so we still have 10 minutes দেখো পারো নাকি So whatever you have learned today, right, it's custom designed so that you can solve this question. So correlator. This circuit is neither series nor parallel. আচ্ছা parallel কিছু properties আছে ওটা show করে না ঠিক মতন series টা একদমই না but it is a circuit so see if you can solve this So find, question to find I1, I2, and I3. That's the question. হচ্ছে না? -1 by আচ্ছা তারা I think that's correct, but Acha, first of all, let me clarify something. How many loops are here? 2. That's the problem. There is one loop here that's the most useful loop যেটা recognize করা হয় না. Which one? The whole one. আচ্ছা loop তো বলছি যে কোনো জায়গায় হতে পারে. This could be a loop, right? What I mean by that is that this is one loop here, right? আরেকটা loop নিশ্চয়ই তোমরা বের করছো হচ্ছে this one here. That's also another loop, right? Direction ignore করো. Direction যে কোনো দিকে দেওয়া যায়. But there's another loop here. কোনটা? The whole thing is a circuit. এটা নিজের একটা loop কিন্তু. So তোমরা যদি wholeটা use করো দেখবে অনেক values instantly চলে আসে. So the whole loop is very important. What was the definition? The sum of EMF is equal to sum of PD in what? A closed loop. The big thing that I've drawn, the current going from here, there. Is that a closed loop? Yes. এখানেও apply হবে. And that's the thing about Kirchhoff law, that it applies in any loop. It doesn't have to be a circuit part. It doesn't need to be like a proper series parallel. Any loop anywhere, you'll find the sum of EMF is equal to sum of PD, right? So if I take the biggest loop here, but before that, আমরা কিছু basic জিনিস করে নেই. Can you tell me what is the current equation at that junction? মানে based on KCL. Yeah, I3 equals to, sorry, I3 or I1 plus I2 equals to I3. Just a second. Right, so I don't think we can solve the whole question. Just actually need to before I let you guys go. Next class, abar notun kore eta korbo, okay? In the biggest loop here, just tell me what the equation is in this big loop here. Jodi ami a direction of loop to use kore, just tell me what the equation is going to be. Should it be 6 minus 2 or 2 minus 6 based on my loop? না 2 minus 6 আচ্ছা তোমরা মনে উল্টা লুপ নিছিলা আচ্ছা doesn't matter but এটা কি হবে 2 minus 6 is equal to what এই পুরো ব্রাঞ্চটার মধ্যে কোনো কি PD এক্সিস্ট করে কোথায় yeah exactly and what's the current through 10 মানে এটার ভিতর দিয়ে যে কারেন্ট এটা কি হবে is it I1 I2 or I3 I1 and এটা সলভ করলে I1 চলে আসবে I1 is basically 0.4 0.4 আসে না হ্যাঁ বুঝছো কেমনে পাইছি 0.4 once you have I1 I2 and I3 টা এমনি চলে আসবে based on the equation and math that we do আচ্ছা anyways আবার বলে দিচ্ছি আমি নেক্সট ক্লাসে এটা করে দিব but this loop is the most helpful loop you have okay it jump starts the whole process right so next class we'll be doing more of these and series parallel derivation আছে ওগুলো করব I2 is the current. No, I2 is the current here, but not there. Yeah, I2 is just here, not there. So if you had a resistor here, you could have used I2. This one. Yeah, so The current in this branch is 20.2 and the current in this branch is 10.6, right? And this is a junction here. We know that whatever current enters the junction must be the same as what leaves the junction. So what should be entering here? Shouldn't it be this plus this, right? So that's 30.8. So that means 30.8 comes here, 20.2 goes there, and 10.6 goes there. Okay, so that's the first one. But then when you come here to this junction, how much current is coming in? 10.6. How much current is leaving? 10.8, right? Is it same? No, right? How much is the difference? 0.2. Now, was it an increase in 0.2 or decrease in 0.2? Increase, right? So that should be a positive value. If it was like 0.4 here, then it would have been minus 0.2
So 0.2 was going here.
right? From there. So this current is 20.2, right? 0.2 goes here. Can you tell me how much is here?
Can you repeat this?
The current here is 20.2, right? And 0.2 goes here, right? How much should the current here be?
20.2 minus 7.
And then when you bring that current here and you bring this current here and you add them, you will see it's still 30.8.